Now, talk about diagonal vector. These are the last categories of vector. Remember, there are four categories of vector. They are parallel vectors, antiparallel vectors, perpendicular vectors, and diagonal vector. So this is the last category of vectors, which are called the diagonal vector. Now, they have angular difference between 0 and 90. Unlike in perpendicular vectors that have angular difference of 90, diagonal vector have angular difference between 0 and 90. It can be 10, it can be 20, it can be 30, it can be 40, it can be just in between 0 and 90. Yes, the angular difference is in between 0 and 90. Remember, parallel vectors have angular difference of 0. Antiparallel vectors have angular difference of 180. Then perpendicular have angular difference of 90. This is because they are perpendicular and they are at right angle. Remember, right angle means angle 90 or 90 degree. While diagonal vector, they have angular difference between 0 and 90. Let's continue. The two vectors are represented by the sides of a parallelogram. Yes, by the sides of what? A parallelogram. Now, these are a parallelogram looks like. Yes, these are a parallelogram looks like. Yeah, so the two vectors are represented by the sides of a parallelogram. At the side of a parallelogram. So these are a parallelogram looks like. Okay, these are a parallelogram looks like. Okay, so these are parallelogram looks like. So the two vectors, they are represented by the sides, by the sides of what? A parallelogram. So if you want to see them in your textbook, it will be something like this. It will be something like this. It will be something like this. The two vectors, they are not perpendicular to each other. I don't know if you understand. Now, most students usually mistake questions coming from diagonal vectors. They mistake it with perpendicular vectors. They also mistake it with the formula. Diagonal vectors, the vectors are represented by the sides of a parallelogram. But perpendicular vectors, they are like this. The two vectors are perpendicular. Students often misuse these two. Question coming out from this, they'll use the formula for this to solve this. Question coming out from this, they'll use this one to solve it. So there are two different things. Diagonal vectors, they are represented by the side of a parallelogram. While perpendicular, the two vectors are perpendicular to each other. So the two vectors are represented by the sides of what? A parallelogram. Then number 3, the magnitude of their resultant is calculated by cosine rule. Now this is how cosine rule looks like. R squared equals to a squared plus b squared plus minus 2ab cos theta. Now, it varies for different textbooks. Some textbook they can put r squared. The letter here can be p. The other letter here can be q. So, but it's the same thing. Yes. So just be mindful that just know that the letter varies, but it's the same thing. And don't mistake it for perpendicular vectors. Remember, to calculate for the magnitude of the resultant of perpendicular vector, make use of Pythagoras theory. But for diagonal vector, to calculate for the magnitude of the resultant, make use of cosine rule. Cosine rule is r squared equals to a squared plus b squared plus minus 2ab cos theta. Pythagoras theory is just r squared equals to a squared plus what? B squared. This is Pythagoras theory. But cosine rule is r squared equals to a squared plus b squared plus minus 2ab cos theta. Now, don't let me continue now. This plus minus, it means that this formula is in, or this equation is of two type. Is of two type. I don't know if you understand. This formula, this plus minus, it means it's of two type. One is r square equals to a square plus b square plus 2ab cos theta. This is what it means. This plus minus means that the formula is of two. R square equals to a square plus b square minus 2ab cos theta. So this is what plus minus 2ab cos theta means here. I don't know if you understand. So the equation or cosine is of 2. Please, most students misput minus here. It can only be in this place. Remember, it's plus or minus. So the first part is always plus, while the second part can be plus or minus depending on the question they give you. I don't know if you understand. Depending on the question they give you. Now, let me tell you how you can use how to know the equation or the formula to use. Is it the one containing plus or is it the one containing minus? Now, how do you know if you are going to use this one or this one in a question? Now, it will be something like this. Okay. Now remember, this is these diagonal vectors. They are the sides of a parallelogram. This diagonal vector. Now the resultant is like this. Their resultant is like this. So to calculate for the resultant, which is the magnitude of the resultant, make use of cosine rule. Any of these. You can make use of any of these. Now, which of the formula can we use? Now, it's so simple to know which formula to use. Now, if the three vectors, that is vector A, arrow and B, they come from the same origin, something like this, make use of this first formula. But if they come from different origin, something like this, okay, let me see. Something like this. Something like this. If you look at this diagram, it's the same thing with this, but like this is still diagonal vector. I don't know if you understand. It is still diagonal vector. When the three vectors come from the same origin, we use the first formula containing plus. But when the three vectors does not come from the same origin, we make use of what? The second formula with negative sign. Now, let me tell you something. Since you are writing jamb or TME or even WAEC, irrespective of the diagram they give you, I just want to tell you. I just wanted to tell you because I just wanted you guys to know these two, like to know which formula you are going to use. Yes. Now, if you're writing jamb TME or WAEC, these things, don't make use of this one. You don't make use of this formula, irrespective of the question. They might even give you diagram with this. If you solve with this, you have your answer. But for A level, like in higher institution, in 100 level, we make you make use of any of them based on the question they give you. But for this current level, make use of this one. Make use of this one with the positive symbol. Even if they give you diagram with this or they give you diagram with this, make use of this first one, please. I just want you guys to just know for the now. But when you are in 100 level or when you are in an institution studying physics or any courses or any physics related course, just know that diagram like this, make use of this one. Diagram like this, make use of this first formula. So, but for this for your current stage now, right, in JAM or pursuit like, make use of this first formula. Make use of this first formula, irrespective of the diagram. Okay, make use of the formula with plus symbol. Okay, so let's continue. The direction of their resultant. Now, the magnitude, remember, vector has to do with magnitude and direction. Now we have to calculate for the magnitude of the resultant. Make use of cosine rule. Now, how about the direction of the resultant? How about the direction of the resultant? What can we use? We use what we call sine rule. The direction of their resultant is calculated by sine rule. Now, in some question, they can give you calculate for the magnitude only. When you question, they can give you calculate for the magnitude as well as the direction. This also applies for perpendicular vector. Remember, in perpendicular vector, we calculate for the magnitude of the resultant using Pythagorean's theorem. While for the direction of the resultant, we make use of theta equals to shift tan A over B. So, but in diagonal vector, the magnitude of the resultant is calculated using cosine rule, while the direction of the resultant is calculated using sine rule. Now, the last but not the least, their resultant represents the diagonal of a parallelogram. Yes. Now, this is how a parallelogram looks like. This is a parallelogram. This is a parallelogram. Now, the line that passes from here to here, this line is known as the diagonal. This line is known as the diagonal, and this is where the word or diagonal vector is where. Okay, this is where the word diagonal vector originates from. So, their resultant represent the diagonal of a parallelogram. This is from the parallelogram law of vector. Parallelogram law of vector talk about the resultant of the diagonal vectors. That the parallelogram law of vector, let me just state it. Parallelogram law of vector state that if the vector, that is vector A and B, are represented by the sides of a parallelogram, the diagonal of the parallelogram represents what the resultant vector. That is what parallelogram law of vectors says. So their resultant represents the diagonal of the parallelogram. Where is the diagonal of the parallelogram? This is the diagonal of the parallelogram. So what parallelogram law says that it says the diagonal of the parallelogram is the resultant. I don't know if you understand. While the sides of a parallelogram is what? The other two vectors. So, in summary, from diagonal vector, we learned that they have angular difference between 0 and 90. The two vectors are represented by the sides of a parallelogram. This was stated by the parallelogram law itself. Yeah. Then the magnitude of their resultant is calculated by cosine rule. The direction of their resultant is calculated by sine rule, which is still look at sine rule. But most questions are not often, does not usually come here more often. Okay, then their resultant represents the diagonal of a parallelogram, which is true. Yeah, this is found in the parallelogram law of vector. Remember, parallelogram law of vector states that if two vectors are represented, or when two vectors are represented by the sides of a parallelogram, the diagonal of the parallelogram represents the resultant vector. So now we move to calculations on perpendicular vectors and diagonal vectors. Watch out for the next video.